Alright, so in this video we're going to talk about the graph of the sine function. Alright, so to graph the sine function, I'm going to use the unit circle and kind of pull points off the unit circle to plot the points on the graph of the sine function. Now, if you recall, the definition of the sine function, right, sine of t is equal to the y-coordinate of the terminal point on the unit circle. Right, so t is my input. T refers to like the pi numbers, the 0, pi over 2, 3 pi over 4. Those are my t values, the inputs to my sine function, and those refer to the distance that we travel around the unit circle. Right, so for the sine function, the input is how far am I traveling around the unit circle, and then my output is, however far I travel, wherever I end up, what's the y-coordinate of that point? The y-coordinate is the output. Alright, so if I'm going to graph this sine function, basically what I'm doing is I'm starting at 0 and I'm traveling around the unit circle and I'm just graphing the y-coordinates of the points that I get. Right, so if I start at t equals 0, which is on the positive x-axis, remember when you start, you're moving around the unit circle, you always start on that positive x-axis. So at t equals 0, my y-coordinate is 0. Alright, so here's 0, right? So here's my y, and this would be my t along that axis, right? So my t value is 0, my y value is 0. All right? So there's my my first point, and then as I move along the unit circle, I didn't put all the points up here just so I didn't have so many numbers written there because I think they would just get too jumbled and too hard to see. But as I move around the unit circle in this direction, in that positive direction, what happens to the y-coordinates? Well, as I move up through that first quadrant, my y-coordinates keep increasing, right? So when I start here, my graph is going to start by going upwards until I get to a t value of pi over 2, where my y-coordinate there is 1. All right, so at pi over 2, my y-coordinate is going to be 1, right? And it's going to increase, obviously, to get from 0 up to 1, is going to increase from there. All right, now 1, though, that's the highest y-coordinate that I have on the unit circle, right? The unit circle doesn't go above y equals 1. So my graph is not going to continue increasing from there. After it goes past pi over 2, and as it's going from pi over 2 over here to pi, going through that second quadrant, well, as I move along the unit circle there, notice that my y-coordinates are decreasing, right? I'm coming downward as I go back towards that x-axis, right? So after I hit that high point at 1, my graph is going to decrease, and when I get to my t value of pi, right, which is halfway around that unit circle, at pi, I have a y-coordinate of 0. Right, so at t equals pi, my y-coordinate becomes 0. All right, so my graph is going to go from 0 up to 1 and then back down to 0. All right, so that's just between 0 and pi. See, my y-coordinate goes up to 1 and then it comes back down to 0. All right, so what happens from there? Well, now as I move through the third quadrant, as I go from pi to 3 pi over 2, now my y-coordinates are negative, right? And they're getting more and more negative, so they're decreasing until at 3 pi over 2, I have a y-coordinate of negative 1. Right? So at 3 pi over 2, I'm going to have a y-coordinate of negative 1, and it's going to decrease from here down to there, right? Decreasing y values, right? They're getting smaller and smaller, more and more negative. And then from 3 pi over 2 to 2 pi, as I complete that one lap around the unit circle and I move through the fourth quadrant, well, now my y-coordinates are still negative, but they're increasing, right? They're coming back up and they're getting closer and closer to 0 as I move through that fourth quadrant. And when I get back to 2 pi, which is, again, the distance around the unit circle, is the circumference of the circle, I get back to my starting point, which has a y-coordinate, once again, of 0. All right, so from pi to 2 pi, the graph is going to go down to negative 1 at 3 pi over 2, and then back up to 0 at 2 pi. And that's what we call one period of the graph of the sine function. Right, one period. The trigonometric functions, we call them periodic. What periodic means is that they repeat the same behavior over and over again. Right, so this is one complete period of the graph between 0 and 2 pi, which corresponds to one complete circuit around the unit circle, right? One lap around the circle, if I graph all the y-coordinates all the way around, that gives me one period of the graph of the sine function. All right, and then if I continue going around the circle from there, like if I go past 2 pi and continue around the circle again, well, I just keep getting the same y values over and over again, right? I'm stuck on that circle. The y values only ever go from 0 up to 1, down to 0, down to negative 1, back up to 0. up to 1, back down to 0, down to -1, back up to 0, back up to 1, and so on. As you keep going around the circle, you just keep cycling through the same y values over and over and over again. And so your graph just repeats itself over and over and over again, right? So from 2 pi to 4 pi, that's going to be another period of the graph. It's going to go from 0 up to 1, back down to 0, down to -1, back to 0. And then there's my second period of the graph. And for negative values, if I start from 0 again, but I go in the negative direction, well, it's going to go from 0 down to -1, and then back up to 0, and then up to +1, and then back down to 0. And I get the same exact pattern in that negative direction. And, I only have enough room on the board to draw basically 3 periods of the graph, but it continues doing that in both directions forever, right? Because you can keep going in the negative direction multiple times around the circle, and every time you do that, you still repeat those same y values. So you still keep getting that same graph, that what we call it a sine wave, in both directions forever. That's what we refer to as a periodic function, right? It just keeps repeating that same exact shape over and over again, right? And the period is 2 pi, right? From 0 to 2 pi, again, 1 full trip around the circle. That gives us 1 period of the graph. And then once we get 1 period of the graph, basically it's almost like you cut and paste, right? You take this and then you just copy it over there. You take this and you just copy it over there, right? And you just keep doing that over and over, and then that gives you the full graph of the sine function, right? So, looking at the sine function, the domain of the function is between -infinity to infinity, right? It goes in both directions forever because we can just keep going around that unit circle multiple times in either direction forever, right? You can do as many laps around the circle as you want, and every time you do that, you're just repeating the same pattern, going up, coming down, back up, going up, coming down, back up, right? The range of the sine function is between -1 and +1. Right? The lowest y value the sine function ever reaches is -1. The highest y value the sine function ever reaches is +1. And again, that goes back to the unit circle. If I'm traveling around the unit circle and I'm stuck on that circle and I can't get off it, well, the lowest y value I ever hit on that circle is -1, and the highest y value I ever hit is +1. I'm never going to get a y above 1 or below -1 if I'm stuck on that unit circle. All right, so that's the domain and range of our function, y equals sine of t. All right, so there's our graph of the sine function. I'm just checking out my notes here to see if there's anything else I wanted to mention about this function. I think that's pretty much it. So the key thing to know for the sine function, and I'm going to do another video in a minute where I talk about the graph of the cosine function, which looks very similar to the graph of the sine function. It has the same wave property. It has the same domain and range. It's just that the starting point is slightly different, right? So the key thing to know for the sine function, sine starts at 0, 0. Right? It starts at the origin, and then from there it goes to the top, to the middle, to the bottom, to the middle, and that's 1 full period. So sine is middle, top, middle, bottom, middle. It goes up and then back down, right? If you ever get confused and you forget, I forget where sine starts or which direction it goes. It all comes directly from the unit circle. So if you haven't seen the other videos that I did on the unit circle and the t values and the terminal points, you should definitely look at all that stuff. And on the definitions of the trig functions, you should watch those too. If you remember the unit circle and you remember the definition of the sine function, your input value is the t, the distance you travel around the circle. The output is the y coordinate of that terminal point. Well, just, put up the unit circle and say, well, when I start at 0, my y coordinate is 0, and as I move around the circle, it goes up to 1, then down to 0, then down to -1, and back to 0, and that kind of gives you the blueprint of how that graph of the sine function is going to go, right? So, again, I didn't want to just draw the graph up here and say, okay, this is the sine graph, you need to know what that looks like. I want to show you where it comes from, because if you understand where it comes from, again, like I said on a lot of the other videos I've done, if you have that understanding, it makes it easier to remember what's going on, as opposed to I just have to fix a picture of this graph in my mind and memorize exactly what it looks like, and if I forget any piece of it, everything's messed up. But if I know it comes from the unit circle, if I do forget it, I can go back to that unit circle and kind of retrieve the information, right? Just go around the unit circle and plot the y coordinates, and you've got your graph of the sine function. All right, so that's our graph of the sine function. Again, key thing starts at 0, 0, then goes up, down, back to the middle. The period is 2 pi. The domain is all real numbers. The range is -1 to 1. So there's the sine graph. And now, just like with other graphs, we can do transformations of the graph. So we can take this and stretch it out this way, or stretch it or shrink it in the horizontal, or shift it to the left or to the right, or shift it up or down. And I'll be doing another video soon where I talk about all those things and how those apply to these trig functions. But the next one I'm going to do is a video about the graph of the cosine function, so it'll look pretty similar to what I did here, so make sure you check that one out, because the sine and the cosine functions, they're similar, but they're different, so you need to know how they're different from each other.